right, so we're going to be doing our Check Your Understanding problems for topic 3.4, which was about related rates. This is one of the hardest derivative applications that we have. It's really important that we know the gist, but it's been, actually there was a pure related rates FRQ 2 years ago. So, but before that it had been a long time. So, check your understanding. A cylinder filled with water has a radius of 2 feet and a height of 11 feet. Water is being drained from the container such that the height is decreasing. That's an important word. At a rate of 0.1 feet per second. How fast is the volume changing? So my variables, I've got radius, height, volume. Those are my variables. It's important to kind of recognize what you have. You've got radius, height. Water is being drained, so the height is decreasing, so we know dH dt. We're looking for dV dt. And the cylinder, if you, assuming you know what a cylinder is like this. Okay. So the radius is not changing. The RDT is 0. Okay, it is a constant, and so you can treat the radius. Well, the radius is 4, so maybe r is not a variable. R is 4. So I write down 3. R is 4 feet, and so the RDT is 0 because it's not changing. What equation relates all the variables in the problem? So I've got my cylinder. It has a radius and a height. But the water's being drained, so there's water in the cylinder. Helps if you kind of make that wiggly curve. But the water is being drained out of this. So the height is changing. But they told me dH dt decreasing. So that means negative 0.1 feet per second. We'll come back to that. Okay, so what equation represents all the variables? So that would be the volume of the cylinder. And the volume of the cylinder is given by V equals area of the base, since it's a circle, that's pi r squared times the height. Okay, so that's the equation for volume of the cylinder. Remember, r is a constant. That is not, let's go ahead and plug that in right now, because the radius will always be 4. I'm not going to plug anything else in, but I am going to go ahead and change r out for 4. So I've got V equals 4 squared is 16. And so that's the equation I'm going to use. I went ahead and put in the constant radius because it is not a variable. Because variable means changing, and radius is not changing. And even though the height of my cylinder is 11, there's water in it, and the water's pouring out, probably from the bottom, by the way. Usually there's a spigot here that will let the water out, okay, because you can't drain it from the top. But anyway, water's pouring out of it. Okay, so actually I did this early. So, never mind. There's my formula, which variables are remaining constant. R is remaining constant. Nothing else is. And so V equals 16, like I said. Let's go slow. Pi 4 squared h, which leads to 16 pi h. Okay, better. Write an equation for dV dt, and don't forget to change. So we're going to go ahead and take the derivative with respect to time. D V dt equals 16 pi times the derivative of h, which is 1, or derivative, right? That's just going to be 1. But then derivative of h is actually dh dt. That's the chain rule part they were talking about. So I've got dv dt equals 16 pi dh dt. Plug in the known values and solve for the quantity we're after. Well, we know dh dt. So dh dt was given to us and it's decreasing. Okay, so dv dt is equal to 16 pi times negative 0.01 feet per second. Now remember, this was feet squared, which I left out. Feet, right? And so feet squared that's feet squared. The reason I bring the units back in is because if you have the units, then you know if you did it right. Volume should be units cubed per time measurement. And so this one turns out to be negative 1.6 pi feet cubed per second, in case you don't believe me. It seems if I keep this up here, kind of off the side, it works out better. Doesn't mess up the screen as much. So 16 times negative 1, negative 1.6. Okay, and there we go. That's it. So again, you can use the units to check that you did it right. Since when I plug in 4 feet, I get 4 feet. 4 times 4 and feet times feet. Okay, should have been more careful about that. Get a little careless about my units. But especially on related rates, units are critical. All right, let's go ahead and go to the last question here. Ashanti and Kale met at Starbucks. Maybe there are a couple and they finally got to meet. Anyway, at Starbucks and are now returning home. Ashanti heads north at a rate of 80 yards per minute. Kale heads east at a rate of 100 yards per minute. After 50 minutes, what rate is the distance between them changing? So, never eat soggy Wheaties. So north is up and east is right. Okay. So draw a picture to represent the problem. So Ashanti's going this way at a rate of 80 yards per minute. Kale is going this way at a rate of 110 yards per minute. And we want to know the distance between them. So we are dealing with Pythagorean theorem. So, and you're thinking to yourself, well, streets never go this straight, but they do in some places. They do in Utah. How it works. There's very few exceptions to that. There are some, especially getting into newer neighborhoods, they get a little more circular. And in the old areas, straight, all the time. All right. Draw a picture to represent the problem. Write an equation that relates Ashanti's distance, x, and Kale's distance. So let's go back to this problem. Ashanti is going to be x. Kale is going to be y. So dx dt equals 80 yards per minute. And dy dt equals 110 yards per minute. And their distance from each other is z. Okay. So that's going to be x squared plus y squared equals z squared. Okay. And take the derivative of both sides. Okay, so let's just go ahead and take the derivative. dx dt is 2x times the derivative of the inside, dx dt, plus derivative of 2y, of y squared is 2y dy dt, oh wait, equals, I said plus, equals d, the derivative of z times dz dt. Okay, now we know what dx dt is and we know what dy dt is. Do we know what x and y are? And z? So it gets a little tricky here. If it's 80 yards per minute and it's been 15 minutes, so it's been 15 minutes, and I should have marked that in red. I'm doing contrasting colors. It's been 15 minutes. So 80 yards per minute times 15 is 120 yards. Okay, so that's how far Ashanti is. So that's x. So y, or Kale's distance, is going to be 15 times 110 yards per minute, which is 1650 yards. Okay, and this is a triangle, x, y, z, so we can find z. So 80, wait, not 80, 120, 1650, z. All right, squaring, 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 square rooting, all that good stuff. So we're going to do and we'll take the square root, find out what z is. So z is approximately, I need 3 decimal places, 1. Okay, there's z. And you can see on my calculator how I got my numbers, that I squared them both, that I took the square root of what I had. All right, plug in the values and solve for the quantity we're after. So x is that, so 2 times x times the rate of 80 yards per minute and this is yards, plus 2, and y is 1650 times 110 yards per minute equals z. So equals to z dz, oh, not sure, it's dz dt. So I'm going to times the answer I have here on my calculator by 2. Okay. And I'm going to divide by that over here. But I'm just going to do all the work here. Again, it looks like I don't have room to write stuff. There we go. 400 yards times 80. And let's slow down. 24000 times 80 yards squared over minutes. And so that's 192,000 yards squared per minute. Plus 2 times 1650 times 110. 3, okay, slowing down. 3300 times 110 yards squared per minute. So I end up with plus 363,000 yards squared per minute. I'm going to divide that by 4080.441, which is that times 2. But the decimal's right because I didn't use that rounded decimal. I used the one that was in my calculator. Okay, yards equals dz/dt. So I'm done. I'm going to clean this up though. 192,000 plus 363,000. The numerator is 555,000. And yards into yards squared. And so I get 272.029 yards per minute is dz/dt. The distance between them is changing at that rate. 15 minutes later, at t equals 15 minutes. Okay, so it's really important that we have that. Not all the way. It's really important that we have all of that kind of information at 15 minutes. All blah, blah, blah. Now this, again, as soon as I divided, I was done. So I could have written this, all this down the way it is, and written divided by 2 times that, and called it a day. Okay. Story problems, I like to know the answer though, so I went ahead and went all the way down. And certainly I wanted to check my units and see if they made sense. So this line is kind of, should be equal to dz/dt. Sorry, make sure my math is good, because then the next line makes sense. Okay, questions? So there you go. Good luck, and we will talk to you. Leave it right there. We'll talk to you soon. Whatever focuses anyway.